analytic function. As you know that for singular point, function of z to be analytic, in which there are two types of singularities. First, isolated isolated singularities. Isolated singularities. If you have a function at function of z at z equal to z naught is a singularity of function of z, where function of z is analytic at each point in its neighborhoods, that is, there exists a circle with the center z naught, which has no other singularities. Such that in the expansion of Lorentz series, function of z equal to a naught a1 z minus z naught plus a2 z minus z naught square plus on b1 z minus z naught raised to power minus 1 b2 z minus z naught raised to power minus 2 plus so on, where a is equal to function of n derivative of z naught upon factorial n, and bn equal to function of minus n of z naught of factorial of minus n. Suppose if function of z equal to cot pi upon z, this function is not analytic, where but tan of pi upon z equal to 0. That means tan pi upon z equal to tan n pi. That means pi upon z equal to n pi. That means z equal to 1 upon n. Z equal to n upon, where n equal to 1, 2, 3, etc. That is z equal to 1, half, 1 by 3, etc. are isolated points. That is singularities. N is large, z equal to 0 is such a singularity that there are infinite number of other singularities in its neighborhood. That means z equal to 0 is non-isolated singularities. Now second part is removal singularity. If all the negative powers of Lorentz series equal to 0, that is function of z becomes an of z minus z0 means in Lorentz series, if the negative power of Lorentz series equal to 0, then the series becomes function of z equal to n equal to 0 to infinity an z minus z0 raised to power n. This type of singularity is known as removable singularities. That means if you consider the finite number of singularities, then it is called removable singularity. If the infinite number of singularities, then it does not exist. After that, you have poles. Poles means limit of, suppose z tends to z0, function of z exists, is known as removable singularity. If limit of z tends to z0, function of z does not exist. Negative powers of z minus z0 in Lorentz series after the nth are missing, then the singularity of z barabar z0 is called poles of simple pole. Poles of simple pole. Otherwise, if you have a pole having more than one order, is known as poles of order n. That means z minus z0 square etc. is known as poles of order n. After that, you have to know essential singularities. Essential singularity. If the number of negative powers of z minus z0 in Lorentz series is infinite, this implies z बराबर z naught is an essential singularities. For example, if you have function of z equal to sine of 1 upon z has an essential singularities at z equal to 0. Since sine of 1 upon z may be expanded as 1 upon z minus 1 upon factorial 3 of z cube sine of 1 upon z 1 upon z minus 1 upon factorial 3 z cube plus so on. This is essential singularities. You have to find out what is the nature and location of the singularities. For example, you have to consider the example of singularities, that is location of singularities. Location of singularity. Suppose you have function of z equal to z minus sine z upon z square. You may write z minus z cube upon factorial 3, z5 upon factorial 5, etc. upon z square. We will get z upon factorial 3 plus minus z cube upon factorial 5, etc. Here there is no negative power of z in the expansion z equal to 0. Here there is no negative powers of z in the expansion at z equal to 0. So it is removable singularity. In this way, you can check whether the singularities, zeros, removable singularity, or essential singularities. You may also check the part. Now your part will start with residue. Doubt, then you may ask the questions regarding zeros, singularities, poles of an analytic function.